Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you all in Pakistan International School Taif Virtual Learning System. Today is our 51st video lecture for grade second year students, boys and girls. I'm Mrs. Rosie Imran, your mathematics teacher. Chapter number 6, exercise 6.1 and 6.2 we already done in our previous lecture. Today we will start 6.3 and 6.3 having only 4 questions, and all questions are included in the reduced syllabus. These are theorem type questions, so we will discuss it now. Exercise 6.3, chapter number 6. First question is, prove that normal lines of a circle passes through the center of the circle. This question is just like a theorem. So what we will do, we have to prove that the lines of the circle, normal line of a circle means um, any normal which passes through the center of the circle. We have to prove that normal line of a circle passes through the center of the circle. Consider circle with a center at the origin and radius r. So if a circle is at origin, so automatically its equation will be x square plus y square equal to r square. Now differentiate with respect to x. So it will be 2x, coefficient will come, power will come in coefficient, and from power we subtract 1, 2x plus 2y dy over dx equal to 0. Now 2x shifted at other side, it will be minus 2x, 2y multiply here, shifted at other side, divide, 2 cancel. So we get dy by dx is minus x over y. Now slope of a tangent at point x1, y1. You know that to find the slope of a tangent, in this we replace x with with the with that point which is given x1, y1. Now slope of normal is, you know that that is perpendicular to the tangent. So slope of normal will is equal to minus 1 over m. We already studied in previous lecture that the slope of the normal is perpendicular to the tangent. Therefore slope of normal is minus 1 over m, means that minus 1 over slope of tangent. So minus 1 over m is minus 1 over minus x1 y1, minus minus cancel. So if something is in the denominator it will come in the numerator. So y1 over x1. Now equation of normal we can easily find it at this point x1 y1 having slope this, and point slope form, you know that y minus y1 equal to m into x minus x1. This point slope form we already studied in chapter number 4. So y minus y1 and m is y1 over x1 and x minus x1. Now throughout multiply with x1 because to remove the fraction. So throughout multiply with x1, x1 y minus x1 y1 equal to y1 x minus y1 x1. So shifted, you know that y1 y1 x1 is present at both sides, so it will cancel. So you get x1 y is equal to y1 x. So clearly center of a circle is 0 0, satisfy equation 1. Hence normal lies of the circle passing through the center of the circle. How can we put the center value, that is 0 0, in this equation? When we put 0 0, so both sides will be equal. When both sides will be equal, so it show that normal line of the circle passing through the center of the circle. Now question number 2. Question number 2 is, prove that the straight line drawn from the center of a circle perpendicular to a tangent passing through the point of tangency. What it means, they are saying that if you draw a line from the center of the circle, so that line will also passes through the line of tangency, means at that point where the line is tangent to the circle, you have to prove that if you draw from the center to the boundary, that line will be passes through the point of tangency. So you know, consider again a circle with center at the origin and radius. You know, when you have a circle at origin, then it will be easy to solve. So x square plus y square equal to r square. Again you differentiate 2x plus 2y dy by dx, constant derivative 0, 2x shifted at other side, minus 2x, 2y shifted at other side, divide, so minus x over 1. Now slope of tangent at x1 y1, you know that you replace x with x1, y with y1, so minus x1 or y1 is the slope of the tangent. Now slope of the line, that is normal line, so that is perpendicular to the tangent, therefore its slope will be minus 1 over m, so minus 1 over x1 y1, just like previous question, that will be y over x1. Now equation of the line is perpendicular to the tangent passing through the point 0 0 origin. So in place of x, point slope form we use in that is y minus y1 equal to m into x minus x1. So in place of y1 and x1 we put 0 0. So y minus 0 equal to slope is y1 over x1, x minus 0. So x1 throughout multiply on both sides, so x1 y1 equal to y1 x. Clearly the point of tangency x1 y1 satisfy equation 1. Hence the straight line drawn from the center of the circle perpendicular to the tangent passing through the point of tangency. Come to question number 3. Same is just like question number 1, question number 2. So question number 3 is prove that the midpoint of the hypotenuse of a right triangle is circumcenter of the triangle. Means that you have to prove that the when you draw the right angle triangle in the circle, you have to prove that the hypotenuse center is the center of the circle. Hypotenuse of a right triangle is circumcenter of the circle. You have to prove that that is the center of the circle. So for this, first of all we draw it. It will help us to solve. So what will we do? We draw the circle at this point. Center we don't know, we draw a right angle triangle. A is the base and b, small b, is the perpendicular and c is the hypotenuse. So what will we do to find c? We find the midpoint of this point b and this point a. Point a is a0, where value of x-axis is a, value of y-axis is 0, and here point B is 0b, where value of x is 0, value of y is b. So to find point C, what will we do? The center of the hypotenuse, we use the midpoint formula. Midpoint formula, you know that if 2 points are given, so midpoint formula is, we already study it in chapter number 4, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So x1 is a, and let OAB be the right angle triangle with OA is small a, OB is small b. Then the coordinate of A and B are A0 and 0b respectively. C is the midpoint of the hypotenuse AB. To find the coordinate of C, what will we do? We use the midpoint formula, x1 plus x2 divided by 2. So A plus x1 is a, x2 is 0 divided by 2, and y1 plus y2, y1 is 0 and y2 is b, so 0 plus b divided by 2. So what we get? A over 2 and b over 2. Now we have to find the distance from C to A. So with the distance formula, you know that that is x2 minus x1 whole square plus y2 minus y1 whole square. So x2 is the coordinate of C is a over 2 and b over 2. So a over 2 minus a whole square plus b over 2 minus 0 whole square. So now when we take the LCM, it will be minus a over 2 and b over 2 whole square, so a square over 4 plus b square over 4. This is the distance from C to A. Now we find the distance from C to B. Again, a over 2 minus 0 whole square, b over 2 minus b whole square. So we get this a square over 4 plus b square over 4. Now we find the distance from C to O. O is the origin 0, 0. So 0 minus a over 2 whole square plus 0 minus b over 2 whole square. So again same. If you check the distance of CA, CB and CO, all are equal. So C is the center of the circumcircle. Hence the midpoint of the hypotenuse of right triangle is the circumcircle of the triangle. We prove it. Now mean proportional, let A, B and C be three numbers. The number B is said to be mean proportional, means that repeated between A and B. If A, B, C are in geometric mean, so B square equal to AC, or B over A is equal to A over C. Now question number 4 is prove that the perpendicular dropped from point drop from a point of a circle on a diameter is a mean proportional between the segments into which is divide the diameter. What it mean? Prove the perpendicular drop from a point. If look, this is the circle at the origin and the perpendicular is dropped from this point. What you have to prove that the perpendicular drop from a point of a circle on diameter, and this is the diameter, you know that, is a mean proportional between the segment into which it divides the diameter. Is a mean proportional means this point is the mean proportional to the segment in which it divides. Consider a circle of radius r and center OO. Then equation of circle is means that consider a circle at the origin with radius r. So the circle equation will be x square plus y square equal to r square. Let A and B are endpoints of diameter. You know that A and B are the midpoints of diameter of a circle along x-axis. Then coordinate of A will be minus r0 and coordinate of B will be 0 r respectively. So P is a point, A, B, be any point on the circle. From this point we drop the perpendicular. P, A, B, be any point on the circle and perpendicular from P, cut diameter at point C. The coordinate of C are automatically x-axis A and y-axis 0. At this point the value of x-axis is A and the value of y-axis is 0. So coordinate of C is A0. Since PAB lie on a circle, therefore a square plus b square equal to r square. So AC, the distance between A and C, we find it, that is x minus x2 minus x1 whole square plus y2 minus y1 whole square. So coefficient or ordered pair of A is minus r 0. So r plus a whole square minus 0 minus 0 whole square. So that is r plus a. AC we find. Then we CB we find r minus a whole square plus minus 0 minus 0 whole square. So r minus a we get. And PC, the distance P and C, that is B. So AC into CB is R plus A into R minus A, that is R square plus minus A square. So value of R you put, that value of R is A square plus B square, this minus a square plus a square cancel, so b square is equal to pc square. So from this we prove that ac into cb is pc into pc. So pc multiply here, shifted at other side, divide, cb multiply here, shifted at other side, divide. So pc is a mean proportional to ac and cb. We prove it. These 4 questions are included in your reduced syllabus, and in this exercise having only these 4 question. I hope you will understand it. If any difficulty, so you can ask in Zoom meeting class. Take care. Allah Hafiz.